Hi, welcome to our third lesson on composite functions, exercise 2C. So composite functions is something that you've done at GCSE, and this is the kind of question you did at GCSE level. So we'll just do a recap of GCSE, and then we'll look at how it looks at it for A-level questions. Okay, so f on g of 1. So you've got your two functions f and g. Now, when you're doing a composite function, you work out the inner first. So you're going to work out what g of 1 is, get that answer and put it into your solution for f. So if I work out g of 1 first, so g of 1 is 3 times 1 take away 2, which is 1. So now I'm going to do f on 1. And f on 1 just means 1 squared because my function, my f function is squaring, so I get my answer as 1. Okay, what about if you didn't have a number here, but you had an x? So we're looking at now g on f of x. So remember, we do our f of x first. So we're doing g on x squared. Now if we just look at what the g of x function says, it's this. Now if you think about this as a box, and then we'll think of this as a box, this means whatever you're putting into g, the function g means you do 3 times whatever you're putting in, i.e. the box, take away 2. So in this case, our box is x squared. So the function g says we're doing 3 lots of x squared, take away 2. So there's my solution. I always tend to think this is easier as a box rather than x, because it doesn't get confused with the other x's. Okay, let's look at the last question here. f on negative 3. So, if I work out f of negative 3 first, well, I know my function for f is squaring, so I get 9. Now I'm going to put 9 into my, because I've worked out this is 9. Now f of 9 just means 9 squared, so I get 81. So that's how you do it for GCSE. Okay, so let's look at what kind of questions you get for A-level. Now for A-level, we're going to involve this modulus sign as well. This is one type of example you might get. So the first question says find f on g of 3. So I'm going to work out g of 3 first. So g of 3 will be 3 plus 1. So just put 3 into here. 3 plus 1 is 4. Divided by 2 gives me 2. So g of 3 is equal to 2. So g of 3 is equal to 2. Now I'm doing f on 2. So remember, f box, whatever's in my box, equals 2 lots of the box minus 8. So I'm replacing the box with 2. So 2 times 2 take away 8, and it's the modulus of it. So 4 take away 8, the modulus. So the modulus of negative 4, which we know we take the positive part of that negative 4. So my answer is just 4. Right, next question. We're asked to solve f on g of x equals x. So to begin with, I'm going to do f on g of x. Now g of x is this. Okay, so I'm replacing the g of x with x plus 1 over 2. Now I know that my function of f box, is equal to modulus 2 lots of whatever is going into F, take away 8. So I've got modulus 2 lots of, I'm putting in this, and then I'm taking away 8. So my box now is x plus 1 over 2. So my function f means 2 lots of the box take away 8. So let's just work out what that is. So my 2's will cancel, so I'll have the modulus of x plus 1 minus 8, which will be the modulus of x minus 7. Okay, so I've worked out what the f on g of x is, and now I want to look at solving it equal to x. So I'll just get some fresh paper. So I want to solve x minus 7, the modulus of it equals x. And we did this last lesson. So the method to do this is I need to sketch my modulus function, and I need to sketch my line graph and look at how many interceptions I've got, and therefore I can see how many answers I've got. So let's look at plotting y equals x minus 7. So it will go through negative 7, and when y is 0, it will go through plus 7. So I'm just going to do a dotted line to begin with. So that's my line y equals x minus 7. Now everything above the line will stay where it is, and everything below the x-axis, or all my y values here, will be negative. So to plot my modulus, I need to make them positive. So my negative 7 will go to 7. So this is my graph here of y equals x minus 7. So in a different colour, if I now plot y equals x, so y equals x, so y equals x will just be a straight line going through the origin. Now, I can definitely see I've got one point of intersection here for A, okay? But do I have another point of intersection? Do these two lines intersect? To decide that, I need to look at the gradients of the line. Well, the gradient of this line, y equals x minus 7, is just 1. And the gradient of the pink line is just 1. Yeah? So therefore these two lines are parallel, therefore they will not intersect. So there's only one solution for this equation here. So to find that solution, to find point A, let's look at finding point A. I'm going to solve, well, this is the negative part of my modulus. So I'm solving this equals x. So let's multiply out the negative sign. So I've got 7 equals 2x, so x equals 7 over 2. Which makes sense, yeah, 3.5 or 7 over 2, it's got to be something between 0 and 7. So my solution is just x equals 7 over 2 for point A. Right, so that was actually a really good question to reinforce what we did last lesson and to involve composite functions. Okay, next. I want to look at now a question from exercise 2C, question 9, and this brings in your ln function and your e function. So we did that with logarithms in Pure 1, so quite a long time ago. So let's just recap on ln and e. Just a quick recap, actually, while we are here on e and l, just a reminder of what those two functions look like. So if I was to plot y equals e to the x, it looks like this, going through 1. And if I was to plot y equals ln of x, it's like this, and it goes through 1. Now, these two functions are inverse functions, and we're going to look at this in my next lesson. And if you notice, if I was to plot those two on the same line, on the same graph, so if I was to plot here y equals e to the x, okay, going through 1, you can see that one is a mirror image of the other if I put, it's a mirror image about the line y equals x. Okay, so you can see this point here was 1, 0, and this point here is 0, 1. The x and y coordinates I've just swapped. And we're going to look at this in much more detail next lesson. But I just wanted to show you that there. Okay, so how do we go about this question? So we want to find q on p of x. So I'm doing q on p of x. So this is my p of x here. So I'm doing q on p of x. Now what does q of x do, or q of my box? Q of my box does e 3 times whatever my box is, take away 1. Okay, so this time my box is ln of x plus 3. So I'm doing e 3 ln of x plus 3, my box, minus 1. Then I'm just replacing what's in here as my box. I'm just comparing it with this layout here. Okay, can we simplify this at all? Because this would be difficult to find the range from what it looks like here. Now remember, e and ln are inverse functions of each other. Like squaring and square rooting are inverse functions. Adding and subtracting are inverse functions. Now, one of my rules of logarithms is that I can bring the 3 up here because it's outside, to make it cubed. Okay? And now I know that e and ln are inverse functions, so they will just kind of cancel each other out. So I'm left with this. So my answer for qp of x equals this answer here. Now I'm asked to find the range. Now to find the range, let's think about what this graph looks like. Okay, so let's get another piece of paper. So I'm looking at the graph of y equals x plus 3 cubed subtract 1. Just checking this is still typing. Sometimes it goes a bit funny. Yeah, it's still typing. So let's think about what a cubic curve looks like. Okay, so if I was to plot y equals x cubed, I get this. Now I'm doing a transformation, I'm adding 3, so that means the graph moves 3 to the left. So this point here, 0, 0, will now go to negative 3, 0. And the whole graph shifts 3 to the left. So that's my transformation. And now what does the negative 1 do? Well, the negative 1 shifts the whole graph down. So I end up with my graph going, this point here will now be negative 3, negative 1, and the whole graph will look like this. So this is y equals x plus 3 cubed, go down 1. Now, why did I plot this? Well, I plotted this to find the range. Now we've got to be careful because the range of the whole of this graph is all my values of y. So y belongs to all the real numbers. However, if we look at the beginning statement in question 9, you can see that we've done what's called restricting the domain. So here, ln of x plus 3, they're saying is only valid for all values of x greater than negative 3. Yeah? So all my values of x, so my domain here is only valid for all my values of x greater than negative 3, i.e. this part of the graph. Yeah, because x equals negative 3 here. So I am only looking at the range of this part of the graph, and this graph will carry on forever. So we can see that it stops, y stops at negative 1. So my range is y is greater than negative 1 and all the real numbers. It can't equal negative 1 because x cannot equal negative 3 in the domain. Okay, another really good question to go through, quite a difficult question there. And now I'm going to set you your learning check. Okay, so this is what I'd like you to do at home and to send to us. You've got compulsory work and optional work. Okay, thanks for listening.